okay? So it all starts here with objective 1, which is writing a number as a product of prime numbers, okay? So a factor is any number that divides a number evenly. In other words, no remainder. A good example of this would be like 3 is a factor of 12. And how do we know that? Well, if I were to divide 3 into 12, notice the answer would be 4, and I would have no remainder. All right? So I know 3 is a factor of 12. 4 is a factor of 12. 6 is a factor of 12, and so forth. Okay? Now, there are very, very special numbers. Okay? And these numbers are called prime numbers. All right? Now, a prime number is a natural number greater than 1 whose only factors are 1 and the number itself. So that's a very math definition, okay? Here's what it's saying. All right? I'm going to erase this real quick. Here's what we're saying. If I were to look at the number 7, notice that the only two numbers that I can multiply to get 7 are 1 and 7. That's it. There are no other numbers that I can multiply to get that. Same thing occurs with like 13. The only two numbers that I can multiply to get 13 are 1 and the number itself. Now, I didn't give you, the book provided this. I literally just copied and pasted this from our book. The first few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and the list keeps going. The list will just keep growing. Do not think odd numbers are prime. I realize a lot of these numbers, 3, 5, 7, 11, 13, 17, 19, they are odd. But 2 is even. Okay? 2 is even, so you got to be careful with this. All right? Now, if a number is not a prime number, then it's called composite. So examples of composite numbers are like 4. So I'm going to go ahead and write that. So I'm going to show you why. So 4 equals 1 times 4, and 4 also equals 2 times 2. All right? So any number that has more factors, okay, is considered to be composite. All right? So numbers are going to exist one of two ways, prime or composite. Now, prime numbers are extremely important for us when we're talking about fractions, because what we can do is we can use prime numbers to help us simplify things. And here's how we can do that. Okay? I put it in all caps. Every whole number greater than 1 has exactly one prime factorization. Okay? Now, what does that mean? Well, Preachy, there are multiple ways that we can identify you. Okay? For example, you can have your photo ID, correct? Mm-hmm. You can also have a social security number, correct? All right? You can also have, let me see here. Your last name helps to identify you. But there is one thing that you have that nobody else in this world has.
Yeah.
Fingerprints. Am I right?
Yeah.
Okay, I mean, we all...
Something else.
Okay, well, what were you going to say?
I was going to say the last name, because it's like in a different...
It's different, but I'm pretty sure there's another family out there with the same last name. Hold on one sec. Sorry, he is like biting my feet. Luckily, Molly's here, so I just put him... I gave Artie to Molly. Okay. I literally just ran up my steps, and I'm not in shape, so I'm out of breath now. So anyways, fingerprints is what basically separates all of us, okay? If you commit a crime, they can figure it out based off fingerprints. Because everybody has their own unique shape, all right? Just like snowflakes. No two snowflakes are the same. A number's prime factorization. I'm going to underline that. A number's prime factorization, it's like its fingerprint. It's unique to every single number. Every single number has a different prime factorization. Okay? I'm going to teach us how to find that. So what's really nice about this, it's actually really, really easy. All right? We use what we call the tree or the factor tree method. And what you do is, if you want to find the prime factorization of 30, all you're going to tell me is give me two numbers that multiply to give me 30. And I don't care what they are. They can be any two numbers. Can somebody help me?
2 and 3.
Two and what?
You said multiply.
Multiply.
Oh, okay. 6.
How about 2 and 15? All right, isn't 2 times 15 30? Now, here's what's nice. That 2 is prime, so I'm going to circle it. That 15 is a composite number, which means I could break it down even further. Two numbers to get 15 are 3 and 5. Now, 3 and 5 are both prime, so I circle them. Notice, if I continuously break down these numbers, I will always arrive at prime numbers. And I know prime numbers are numbers whose factors are only 1 and the number itself. So what I just found right here is the prime factorization of 30. In other words, I found its fingerprint. Okay? Let me do my box a little bit better. There we go. All right? So 30 is going to equal 2 times 3 times 5. Okay? Finding prime factorizations, like I said, it's a simple process. You just got to take your time with it. All right? Let's try another one. Let's try 56. All right? So I need two numbers that multiply to give me 56. Okay? And I'm going to give you a little hint here. If the number is even, and 56 is even, all right? Remember, even numbers end in 0, 2, 4, 6, 8. All right? So if the number is even, you can always write a 2 there. The only thing is you got to figure out what the other number is. So you just go off to the right and just divide. 2 goes into 5 twice. 5 minus 4 is 1. Drop the 6. 2 goes into 16 8 times. So 2 times 28 equals 56. Now, 2 is prime, so I circle it. 28 is composite. I can break that down even further. So 28 is 2 times 14. Now, 2 is prime, so I circle it. 14 is composite, so I can break that down into 2 times 7. So 56 is going to equal. Now, personally, I like to just write this out. So I will write out the multiplication of all the circled numbers, all my primes. 2 times 2 times 2 times 7. Okay? Are there any questions there? All right. Go ahead and try to do 72 for me then. Find the prime factorization of 72. All right, did anybody get an answer yet? Okay, I'll wait.
Can I say something?
Sure.
Is it 72 times 2?
I don't, Savannah, I don't know yet. I didn't do the whole problem yet.
Okay. Well, I got an answer. Okay.
All right, go ahead. Could you give it to me one more time?
Okay, so 72 equals 2 times 2 times 2 times 9.
No.
No.
No, because the 9 is composite. That can be broken down even further. Okay?
Okay, break it down. Okay. Okay.
All right, did anybody else get an answer?
I did.
What'd you get?
I got 2 times 2 times 2 times 3 times 3.
All right, I like that one a little bit more. So let's just see how it works now, okay? So 72 I'm going to break down, and I'm going to use 8 times 9. Because I know 8 times 9 is 72. Now, neither of those numbers are prime, so I'm going to break that down even further. 8 is 2 times 4. So now I have a prime number of 2. And 4 can be broken down into 2 times 2. Now, let's work on the 9. 9 is 3 times 3, and they're both prime. So I have 3 2s and 2 3s. So 72 equals 2 times 2 times 2 times 3 times 3. So, Tanisha, excellent. Savannah, you just had to break down a 9 just a little bit further. Okay?
Okay.
All right. How are we looking so far, everybody? All right. I don't want to try to jump the gun here a little bit, but here's what we're doing. If I gave you a problem like this, if I gave you the fraction 56 over 72. Now, whenever we have fractions, we always want to make sure, all right, we always want to make sure that we're in completely lowest terms. All right, meaning we want a simplified fraction. What we can now do is write the fingerprints okay, of each of these numbers. All right? And that's going to help us. That's going to help us to actually simplify this fraction. Okay? Any questions so far? Because that's what we're doing. This is where we're leading up to. All right? Letter D and E, I'm going to let you do them on your own. Because I want to go ahead and teach us how to simplify this fraction here. Because we're gonna be doing a lot of these prime factorizations. All right? All right, so here we go. Sorry, I just wanted to make sure I was on the right thing. All right? So first, sorry, I didn't scroll up enough. So in objective 2, now what we're going to learn how to do is write a fraction in simplest form. I have 3 examples here. 2/3, 4/6, and 8/12. Now, these are all the same fraction. And how do we know that? I'm going to show you. Let me get a different color here. So I'm going to use red. And what I'm going to do is just go ahead and just highlight the very first rectangle. Because it's kind of hard to see. But notice, all of those rectangles are the same exact size. The shaded region is a little bit different. I mean, in 2/3, just one big rectangle. In 4/6, it's broken down into like 2 little ones. And then in 8/12, you have like 4 littler ones. But the fact remains, they're all the same exact size. So 2/3 is equal to 4/6, which is equal to 8/12. The question becomes, How do I go from something like 8 over 12 and break it down into 2 over 3? That is the question. To help us do this, we need these two properties right here. The first one in yellow says that any non-zero number, n divided by itself, is equal to 1. So 5 over 5 equals 1. 17 over 17 equals 1. 24 over 24 equals 1. We learned that in the previous section. All right? Like I said, if I had 4 over 4, that equals 1. Why? If I had a pizza with 4 slices and every single slice was shaded in, you would have 4 over 4, or 1 whole pizza. The other gold box is one that we kind of forget about. All right? And I want to show you that right here. Here you can see that I have two different things being multiplied in the numerator. The first one is A, the second one is C. In the bottom, I have two different numbers. The first one's B, the second one's D. I'm allowed to break them up if I wanted to. I can do that. Okay? I'm allowed to break them up if I wanted to. We're going to use both of these properties in the gold boxes to help us simplify something. All right? So, if we look at 4/6, for example, actually, let's look at the one we just did. Let me copy and paste this. 56 over 72. Let me copy and paste this, because we did this one together. Here we go. All right, so first things first. Notice I wrote the prime factorizations. Well, I didn't. You did, because you gave me the answers. You gave me the prime factorizations for 56 and 72. Okay? My goal is to break this down into its simplest form. Notice here, here, and here, you have a 2 in the numerator and a 2 in the denominator. Is that correct? Yes or no? Okay? Also, if I wanted to, I could break this up as such, using that second property. Notice all I did was, if the numbers were the same on the top and the bottom, I just grouped it together and separated it from everything else. Okay? Now, at the end of the day, we know 2 over 2 equals what number? You could tell me, or you could just show me with your hand. 2 over 2 equals 1. Times 2 over 2 equals 1. Times 2 over 2 equals 1. Times 7 over 9. Because 3 times 3 is 9. And we know no matter what, 1 times any number is that number itself. So, 56 over 72 is the same as 7 over 9. This is what we call the reduced or lowest form. Does that make sense, everyone? See, gone, hopefully, are the days of asking yourself, am I done simplifying? You will know when you are done, and it's because you've broken it up and you've created as many ones as you could. There's nothing I could do with that 7 divided by 3 times 3. Nothing I can do there. So I know I'm done. Does that make sense, everyone? Okay? So if we go back into our notes here. Sorry, am I moving too fast? I feel like I'm moving fast. Okay. So if I go back over here to my notes, that's exactly what I'm showing you with this example right here, the 4 over 6. What we do is we write the prime factorizations of each. Okay? I noticed that I can break this up into 2 over 2 times 2 over 3. This 2 over 2 turns into a 1. So what I'm really left over with is just 1 times 2 over 3, which is 2 over 3. So in general, when we sum everything up, we can use this model to basically simplify any fraction that we want. And I've given you steps on how to do this, okay? I've given you the steps, and the steps are on the next page. And here are our steps. Step 1, you're going to write the prime factorizations for the numerator and denominator. Step 2, write the fraction so that numbers that are in the numerator and denominator are arranged in columns. All right? I want the same numbers, okay? Step 3, we're going to use this property, n over n equals 1 to simplify. And then 4, just multiply what's ever left over in the remaining numerator and denominators. So I'll do letter F. You are going to do letter G, okay? Preach, I see you frantically writing these steps down.
Yeah.
You know you can print up these notes.
I did. I guess I should print them up, but I couldn't get paper.
That's okay. That's
So
okay.
I'm gonna print that out and then copy it down.
That's okay. Just let me know if I'm moving too fast because I know you're copying it down, all right?
Yeah, I will.
All right, so here's what I'm going to do. I'm going to do the prime factorization of 30. So 30 is 5 times 6. 5 is prime. 6 breaks down into 2 times 3. Now notice we did the prime factorization of 30 before. Remember that earlier in the class? And I chose 2 times 15. It doesn't matter what you pick. Every single number has a unique prime factorization. So 30, 2 times 3 times 5. Now let's go ahead and do 45. 45 is going to be 5 times 9. 5 is prime. 9 is 3 times 3. They're both prime. Now, one thing I do like to do is write them in order from smallest to largest. Okay? So here's what I'm going to write. I'm going to do it in red because now this is like, the important part. 30 over 45 equals 2 times 3 times 5 over 3 times 3 times 5. Okay? Now, I like to put little arrows where I see things that match. If we wanted to, we can break this up. And then we just simplify. I know 3 over 3 is 1 and 5 over 5 is 1. So 30 over 45 reduces down into 2/3. Does that make sense, everyone?
I have a question.
Go ahead, Mike.
So what if see how 30 we got 3 numbers?
Yeah.
Prime factorization. So what if the bottom number we only got 2?
That's okay.
Top one we had 3.
That's okay.
What would you put though?
Why don't we?
You have 3 on top and you only have 2 on the bottom. Like if 45 only broke down into 2.
Yeah. Then
even if 30 only broke down into 2.
Then you write down what you have, and you look for numbers that are the same on the top and bottom, and you separate them. All right. Let's look at Let me see, which one would that happen with? Well, here, Mike. Here. Let's go back to this problem. Notice here we had 4 numbers, 4 total. And down here we had 5 total, correct?
Oh, okay. Heard that.
All right. So that doesn't matter to me. What matters, numbers that are the same on the top and bottom, I group together. Because I know they will always go to 1. Does that make sense?
Yeah. All right.
Okay. I like that question. I got to be honest with you, when I was picking these problems, that never even occurred to me. All right. You guys get to do G. Go ahead. Okay, are we ready? Leah, what'd you get?
I got 12 over 20 equals 3/5.
I got that too.
All right, so let's just see if you're correct, okay? So the 12, I'm going to write the prime factorization, 2 and 6, 2 and 3. So hopefully we all got 12 is equal to 2 times 2 times 3. 20 is 4 and 5. And the 4 could break down into 2 times 2. So 20 equals 2 times 2 times 5. So now when I go ahead and I rewrite this fraction. Oh, let me write it in red. I can see here in this big box 2 over 2 and 2 over 2. So that whole thing is going to equal 1. Is that correct, everybody? All right. So you may see, sorry, my keyboard was turned off. Give it a second here. So you may see people do something like this. How many, and just let me know, how many of you have seen people do this before? How many of us have seen that? That's fine with me, okay? Because here's what we know. 1, 2, 3, 4. I know 2 over 2 is 1. So that's like a big fat 1 there. This is going to be a big fat 1. We say that they cancel, but that's a really bad word. It's a really bad word because they don't cancel. If you think of the word cancel, that means eliminated, gone. It's not gone. It just turns into a 1 because you have 2 over 2, okay? What's nice, what's ever left over is going to be your simplified fraction. Okay? Now, the only way we get good at this is just practice. That's it. You just got to practice. So, let's go ahead. Let's look at the next one. 39 over 51. 39 can break down into 3 times 13. And they're both prime. Got the wrong marker here. 51, well, that can break down. Let's try it here. 3 divided by 51, or 51 divided by 3. 3 goes into 5 once. So 3 times 17. Okay? Like I said, the only way you get good at this is by practice. Worst case scenario, honestly, worst case scenario, just do this. If you're looking, you should be looking up at the screen right now. Worst case scenario, just get out a calculator. Start typing in 51 divided by 2. Since it's a decimal, it doesn't work. 51 divided by 3. 17, it's a nice whole number. That's the one you use. Does that make sense? Like, save yourself a little bit of time. So, 39 over 51 is going to equal 3 times 13 and 3 times 17. We know the 3's reduce. And what's ever left over is your answer. Are there any questions so far? All right, let's keep moving then. If there's a negative sign out front, that doesn't mean anything to us. It just means that our fraction's negative. When you're simplifying, you are only concerned with the numbers. Nine is just 3 times 3, so I'm just going to write that. I'm going to leave it like that. That 50, however, I got to break down. So I'm going to use 2 times 25. Now, 25 is 5 times 5. Excuse me. So, do I see any numbers that are the same in the numerator and the denominator? Yes or no?
No.
No. So, Tanisha, can this even be reduced?
I don't know.
Well, do you see numbers on the same in the top and bottom?
No.
Then you can't reduce this. Yeah. So, since there are no common numbers in both the numerator and denominator, this fraction cannot be simplified. So, unfortunately, you wrote down the prime factorizations of each, but it didn't help. But that's a good thing. Because like I said, you will be able to visually see whether or not you're done. So negative 9 over 50 does not simplify. It's just negative 9 over 50. There's nothing you could do there. I know a long time ago, and maybe this is in your head, you were taught to simplify fractions. Like if they're both even, divide by 2. You remember that?
Yeah.
Rachel, you remember that. You're shaking your head. As soon as I said it, you start shaking your head yes. Here's the thing. In your book, they go over that. It's called divisibility rules. And they're really good. And what they allow you to do is allow you to simplify a fraction very quickly. However, you never know when you're done unless you're really, really good at that method. With what I'm showing you, writing out the prime factorizations of each number, and then just kind of going through and looking for the numbers that are the same in the numerator and denominator. Look at these examples we did. I'm going to zoom out here. You can visually see when you are done. Like you can visually see it. There's nothing else you can cancel. So you know you're done. And I said the word cancel and I shouldn't have. It comes out every once in a while. Okay? Let's do this last one here. Oops, sorry. 6x to the second divided by 60x to the third. I'm going to be honest with you. The variables are the easiest part here. They're the easiest one. I know you see them, x to the second, x to the third, and you're like, oh, we didn't do one with letters. I'm telling you, the letters are the easiest part. Let's worry about the numbers first. 6, we're going to break down into 2 times 3. 60 is going to be 6 times 10. The 6 will break down into 2 times 3, and the 10 will break down into 2 times 5. So now what I'm going to do is I'm going to write everything out. Now, if you want, just watch the screen real quick. Because when I say I'm going to write everything out, I mean it. 6 is 2 times 3. And then x to the second, we know, means x times x. 60. Well, 60, let me write it out in order here. 2 times 2 times 3 times 5, okay? 2 times 2 times 3 times 5. And then I have x to the third, so I'm going to write 3 x's. Okay? Now I'm going to break up my highlighter because I'm going to highlight numbers that I see that are the same in the numerator and the denominator. So once again, if you just want to watch the screen, watch how I highlight this. Those are the same. Those are the same. Those are the same. And those are the same. Now, if you're still watching a screen, which I recommend, watch what I do. 2 over 2, that's the first one. That's this. 3 over 3, that's the second one. X over X and X over X. Now, I'm going to write whatever is left over. Notice in my numerator, and this is why I hate the word cancel, because cancel means it goes away. Here's what we know. 2 over 2 equals what? Tell me or show me with your hand. 2 over 2 equals 1. 3 over 3 equals
1.
X over X
1.
and X over X.
1.
So if you ever run into the situation where you end up with nothing, and I'm using this term lightly, if you ever end up in the situation where like you don't have anything left over in the numerator because you simplified it, you put a 1, regardless if it's in the numerator or the denominator. Now, in the denominator, I'm going to write whatever's not highlighted. 2 times 5 times X. Does that make sense, everyone? And my final answer is going to be 1 over 10x. Because 2 over 2 is 1. 3 over 3 is 1. X over X is 1. And X over X is 1. Now, I realize I really wrote everything out here, but I wanted you to see how this simplifies down. So 6x squared over 60x to the third power is equal to 1 divided by 10x. Okay? Every single simplification can be done using this technique. When you get fast and better at this, it goes by much quicker. All right? But for now, take your time. Are there any questions? All right, let's move on. So now we're going to determine whether two fractions are equivalent. And that's a key word there, equivalent. What I'm asking is, if I give you two fractions, how do I know they're equal? I think the easiest example is this. 1/2 and 5 over 10. Are they equal? Yes or no?
No.
Are you sure?
Yeah, they are.
I mean, Praichi, if I wanted to, watch this. There's 1/2. Two, three, four. I should.
They are, yeah.
Yeah, I should have shaded it this way. 1, 2, 3, 4, and 5. Notice that they take up the same amount of space. So they are equal to each other. But there's an easier way than just drawing pictures to do this. And this is the only time you're allowed to do this. Okay? To determine if two fractions are equivalent, all you have to do is cross multiply. That's it. I know a lot of us remember cross multiplication, but none of us know when you're allowed to do it. The only time you're allowed to cross multiply is when you have a fraction equal to another fraction. That's it. That's the only time you're allowed to do this. Okay? So if I go back to my little example here off to the right, the 1/2 equals 5/10. Visually, we know they're equal. Well, now let me show you using cross multiplication that they're equal. What I'm going to do is I'm going to cross multiply, meaning I'm going to take 1 times 10. And then I'm going to take 2 times 5. And I always like to write it out first. Now, we know An equal sign means that the left and the right are the same exact thing. 1 times 10 is 10. 2 times 5 is 10. Because these are the same, I know those two fractions are equivalent. Does that make sense, everyone? All right. So we got 2 examples left. Determine if 7 over 9 and 21 over 27 are equivalent. All you have to do is cross multiply. So we'll set it up. Now, I'm going to cross multiply. 7 times 27 equals 9 times 21. All you're going to do is multiply them. I'm going to do it off to the right here because I can't do this in my head. 27 times 7, well, that's going to be 49. 7 times 2 is 14 plus 4 more is 18. Now we're going to do 21 times 9. 9 times 1 is 9. 9 times 2 is 8. 18, I'm sorry.
Couldn't you just do it? How, like, I saw 7 and 21, and I know 7 goes into 21 3 times, so I did 9 times 3, and it was 27.
Yes, Mike, you can also do it that way.
All right.
All right. That is a decent method, but it kind of goes downhill once the numbers get large.
Okay.
You know what I mean?
Yeah.
All right. And the last problem. 4 over 13 and 5 over 18, are they equivalent? So once again, we'll set it up. We're going to cross multiply. 4 times 18 equals 5 times 13. 5 times 13, I could do that in my head. I know that's 65, but the 4 times 18, I can't. So I'm just going to go over here and just write it out. 4 times 8 is 32. 4 times 1 is 4, plus 3 more is 7. So notice 72 does not equal 65. So you put no. So those two fractions are not equivalent. How we looking?
Good.
Pretty good? All right, so are there any questions? All right, well, I know this is going to sound crazy, but section 3, multiplying and dividing fractions, very, very easy. All right? It's super simple. Because all you got to do when you multiply fractions is just go left to right. That's it. So let me show you what I mean first. Okay? So visually, let's say we wanted to multiply 1/2 times 3/4. All right? So what I did here is I started off by writing a visual representation of 3/4. So 4 blocks shaded in 3. Now, if I want to multiply 1/2 of that, all I have to do is cut them in half and count, excuse me, the shaded regions. So notice, oh, I did it the wrong way. So notice first, the total amount of blocks I have is now 8. But of the shaded regions, I went 3 of them. So these are heavily shaded right here. So I have 3 of them. So 1/2 times, or 1/2 of 3/4 is going to be 3/8. Once again, let me do that again one more time. I draw 3/4, I cut it in half, and I only want 3 of these. So I heavily shade them. So that's what this picture is down here. That's visually what's happening when we multiply fractions. Algebraically, here's what I did. I wrote 1/2 times 3/4, and I told you at the very start to multiply fractions. You just go left to right. 1 times 3 is 3. 2 times 4 is 8. 3/8. That's it. That's how hard it is to multiply fractions. You just multiply from left to right. But here's the catch. Anytime you have a fraction, you got to simplify. Okay? It's always easy if you simplify first and then you multiply second. So let me show you what I mean with this example right here. This 3/7 times 5/11. What do we notice about 3, 5, 7, and 11? All those are very special numbers. What are they?
Composite.
Oh, the other word.
Prime.
They're all prime. So if these are all prime numbers, can they be broken down any further? Yes or no?
Yes.
If they're prime, you cannot break them down any further, which means this. If you were to multiply 3 times 5 and then 7 times 11, you already know your answer is completely simplified. And the answer is or the question is, how do you know that? If you could simplify, you could have did it at the very start. But since you cannot, your answer cannot be simplified either. Does that make sense, everyone? Let me show you another example, and then we'll call it a day. I'm going to write this one down. Five over 7 times 21 over 25. Watch what I do here. I know that 5 is a prime number. I can't break it down any further. The 7 is a prime number. I can't break that down any further. The 21, however, I can definitely break down 21. 3 times 7. Does everybody agree with that? Now that 25, I can break that down. 5 times 5. Does everybody agree with that? Now, I'm going to look for numbers that are the same in the top and bottom. I'm going to look for numbers that are the same in the numerator and denominator. I'll highlight them for us. And the reason why I highlighted them is so I can write it like this. Now, the very last fraction is the ones that are not highlighted. What do we know about 5 over 5?
1.
And what do we know about 7 over 7?
1.
So, at the end of the day, 5 over 7 times 21 over 25 equals 3 over 5. Notice something very special happened here. I simplified first using my techniques from the previous section. Whatever was left over happens to be the answer. That will always work. I mean, if you wanted to, here, I'm going to show you, because I know we're at the end of class. So I'm going to get out my really fancy calculator here. 5 times 21 is 105. I'm going to write that underneath here. 7 times 25 is 175. Here's the question. Are these equivalent? Which we just learned to do. Well, we know cross multiply. So let me move my calculator. There we go. So if I were to cross multiply, and then go ahead and multiply them out. So 5 times 105 is 525. And 3 times 175 is also 525. Could you imagine trying to simplify the fraction 105 divided by 175? You totally can do it. We will pick up where we left off here, okay? The key to multiplying fractions is to simplify them first. Because once you simplify first, you know whatever is left over is going to be your simplified answer. Does that make sense, everyone? Okay? So I don't want to rush this. Like I said, we'll pick up where we left off on Monday.